There is a kind of stillness that exists far from the noise of planets. A silence not just of sound but of change, where orbits crawl, and the sun is only a pale star among countless others. It is here, in this quiet borderland, that something begins to move, not because it wants to, but because the pull of gravity is patient, and patience is stronger than speed. At first, it is nothing more than a faint shift in position, an almost invisible curve in a path that once seemed straight, for ages untold. It has been gliding through the darkness between stars, a darkness so wide that the mind can only pretend to measure it. This is the realm of interstellar space, where distances are not counted in kilometers or miles, but in light years, the long steps taken by light itself over the course of a year. Yet now it is entering a new domain, one where a single star's gravity begins to matter. The sun's realm is not defined by light, for its glow reaches much farther than its gravity can hold. Instead, its domain is drawn by the strength of its pull, the invisible hand that keeps planets tethered in their endless paths. This is the heliosphere's edge, a vast bubble inflated by the sun's wind of charged particles pressing against the thin interstellar medium outside. Beyond it lies the cold expanse where this newcomer has drifted for lifetimes. Now it is crossing that invisible threshold, slipping quietly into the sun's slow embrace. You would not notice it if you looked at the night sky. It does not blaze like a comet with a shimmering tail. It does not gleam like a planet reflecting the sun's brilliance. It is small, dim, and unhurried, a speck lost in the sea of stars. Yet to astronomers, it is unmistakable. Its speed, its angle, its path through the constellations, all point to one truth. It is not from here. When scientists speak of it, their voices are calm but weighted. An object from beyond the solar system is rare, and its arrival is as fleeting as a deep breath. They measure its position against background stars, night after night, gathering the small changes that will reveal its orbit. From these changes, a pattern emerges, a hyperbolic path, open-ended and steep. Unlike the closed ellipses of our planets, this path will not loop back. It will come once, then leave, never to return. You think of how far it has traveled. Perhaps it was born in the disk of debris around a young star, scattered outward by the pull of a massive planet. Perhaps it wandered for millions of years, passing unlit giants and frozen oceans, carrying with it the dust of alien skies. For all those ages, it was anonymous, unseen, and untouched. Only now, in the final stretch of its journey past the sun, does it meet the gaze of human eyes. It is easy to imagine it as shy, reluctant to show itself. Its reflected sunlight is faint, flickering with its rotation, almost as if it were turning its face away. Yet its path is confident, guided by nothing but the quiet inevitability of physics. It will pass through the solar system like a shadow, moving across a wall, smooth, unbroken, unbothered by our questions. To understand it is to understand the idea of escape velocity. Every world has one, the speed an object must reach to break free from its gravity. Our moon's is low enough for a spacecraft to depart with ease. Earth's is higher, requiring a fierce push from rockets. The sun's escape velocity at the distance of Neptune is immense, yet this visitor already exceeds it. It is a traveler whose ticket out is already paid, no matter how close it comes in that way. It is different from the comets that grace our skies. Comets are bound to the sun, circling in slow, distant arcs, until a chance encounter with a planet or a tug from another comet changes their path. This object is not bound. Its orbit is open, infinite. It has no home here, only a passing moment. Still, even a brief visit can leave a mark. Scientists will learn from its light, from its faint color, from the way it brightens and dims. These are the clues to its size, shape, and surface. Each photon reflected from it is a tiny messenger, carrying a story of texture and composition. Some wavelengths hint at ice, others at rock, others at organic dust baked by radiation. Though distant, it will speak to those who listen closely. You think about how many such objects must be out there, unseen. Every star likely sends them out, debris flung during the chaotic years of planet formation, or loosened over time by gravitational nudges. Some will wander for eons without ever approaching another star. Others, like this one, will drift into a new sun's domain, crossing an alien planetary system before vanishing again into the dark dot. It makes you realize how porous the boundaries of solar systems are. The sun may feel like the center of a sealed world, but it is not. Its edges are open, and the space between stars is not empty but alive with motion. These interstellar visitors remind us that we are part of a larger exchange, that the universe is not a collection of separate locked boxes, but a web of constant movement. Some will ask if it could carry life, or at least the seeds of life. That is a harder question. The cold between stars is merciless, and the radiation can strip molecules apart. But some organic compounds can endure, locked inside protective shells of ice or rock. It is possible that such objects once carried ingredients for life between worlds. Whether this one does is not yet known. As you let your thoughts drift, you find comfort in the slowness of its journey. It has traveled for millions of years without urgency. It will pass the sun, swing gently around, and be gone, continuing its path long after you and everyone you know have faded from memory. Its patience is not human patience. It is the patience of the cosmos. For now, it moves silently closer, crossing the invisible boundary where the sun's influence grows strong. It has not yet met the planet's pull, has not yet felt the warmth of sunlight on its cold surface. That will come, and when it does, the shadow at the edge of the sun's realm will step into the light, however briefly. But what will that light reveal? The answer lies in the days ahead, as the visitor continues its slow descent into the inner system, and as you, watching from your small world, wait to see the shape of a stranger, you begin to understand that the universe is not still. Even when you look up and the stars seem fixed, they are drifting, carrying their planets, their clouds of dust, and their invisible debris along invisible lanes. In this endless migration, stars pass near one another, not close enough to touch, but close enough for gravity to reach across the gap and alter the paths of smaller things. And when that happens, stones are sent from one star to another. A star is not only a source of light, it is a gravitational well, a basin in the cosmic landscape. Around it, planets circle in quiet obedience, while comets and asteroids wander on longer, looser paths. But these orbits are not perfect prisons. Sometimes a large planet, like our own Jupiter, pulls at a passing object with enough force to fling it outward. If the push is strong enough, it can send that object over the edge, out of the star's domain entirely. Once freed, the object belongs to no one. It sails into the interstellar ocean, carrying with it the history of its birthplace. Its minerals, its ice, its dust, all are formed from the chemistry of its home star. It may be a tiny rock or a mountain of frozen water, But in either case, it becomes a messenger, carrying a fragment of one world to the vast, dark spaces between worlds. The distances involved are too great for your ordinary sense of time, even at tens of thousands of kilometers per hour. A body like this will take millions of years to reach another star's domain. It does not hurry. There is no rush in the mechanics of the cosmos, only inevitability. It drifts, bathed in starlight, so faint that even the nearest sun may be no brighter than a faraway planet in our own sky. You think of Earth's own history, of exchanges. Scientists have found meteorites on our planet that began their journey on Mars, blasted away by ancient impacts. We, too, have sent fragments of our world into space without meaning to. Shards of Earth's crust, melted and hurled outward by collisions, destined to wander for ages. Some may have escaped the sun entirely, becoming part of the interstellar population. If any such stone ever lands on another world, it will carry traces of our minerals, our isotopes, perhaps even the chemical whispers of our biology. This process has a name, though it is gentle enough in concept to need no label. The exchange of matter between stars. Over the lifetime of the galaxy, it may have happened countless times. Each star system is both a sender and a receiver, though the arrivals are so rare that a civilization may witness only a handful in its history. When you look at the object now entering the solar system, you begin to imagine its past. It may have once been part of a planet's surface, or the core of a comet from a system much like ours. Perhaps it circled its parent star for hundreds of millions of years before a chance encounter with a giant planet gave it the speed it needed to escape. From there, the path was long and lonely, no close passes, no collisions, only a steady glide through the cold. In that time, it has been shaped by the interstellar environment. Its surface may be darkened by cosmic rays, tiny high-energy particles that strike it over and over, altering its chemistry. It may be coated in dust from other travelers, a thin skin of material that tells of countless silent meetings. Its shape may be irregular, a relic of the impact that freed it, or of ancient erosions from frozen gases escaping into space. When such a stone finally reaches another star's realm, it enters a new gravitational story. The sun's pull begins to curve its path, bending it toward the planets within. This bending is subtle at first, like the slow turn of a drifting boat when it feels the edge of a current. But the closer it comes, the more the pull grows, drawing it into a loop around the sun before it continues onward. Changed in direction, but not in purpose. There is a quiet poetry in the idea that stars send each other such gifts. They are not meant for anyone. They carry no intention, no design. And yet, they are the most ancient of letters, physical messages written in the minerals and molecules of their making. To study them is to read about a place you may never see, using only the language of matter and motion. In this way, the object now in our skies is not just a curiosity, but a reminder. It tells you that our solar system is not an island. We are part of a network, not bound by cables or radio waves, but by the silent exchange of stone and ice across the galaxy. The stars are not alone in their courses. They are bound together by the slow trade of their debris. And if stars can send stones to one another, you begin to wonder what else might be exchanged. Could the molecules that form the basis of life survive such journeys? Could an interstellar traveler carry not just the materials of planets, but the instructions for life itself? The thought lingers, not as a claim, but as a question, one that stretches far beyond your own world and time. The visitor in our skies may be an answer to nothing. It may simply be a piece of another place, passing without contact, revealing only its shape and brightness before fading away. But even so, its journey is part of a pattern, one that links the fate of all stars. For in the great timeline of the galaxy, the sending and receiving of stones is as natural as the rising and setting of suns. And now, you watch as this stone, this fragment of another star's story, approaches the inner places of the sun's realm. It carries no message you can read in words. Yet in its presence, you feel the reality of a larger, older conversation. One that has been going on for billions of years, long before any eyes looked up to see it. You tend to think of the space between stars as a void, a black nothing that stretches forever. But space is not truly empty. It is more like a great, slow river, one that moves not with rushing water, but with a scattered flow of particles, dust, and frozen bodies drifting in silence. Some of these are as small as grains of sand. Others are mountains of ice and rock, hundreds of meters or even kilometers across. All of them are carried along by the faint currents of gravity, their paths shaped by encounters long past. The object now entering the sun's realm has been part of that river for longer than you can easily imagine. It is not young. It has traveled through regions where the nearest star was no brighter than the faintest point of light in your sky. It has crossed places where even that light was hidden behind dense clouds of interstellar dust. Its journey has been one of patience, the patience of something that has no destination, no hurry, and no awareness of time. If you could follow its path backward, you might see a different sky. Perhaps it was born in a place where stars formed in clusters, crowded together in their infancy. Perhaps it shared space with dozens of suns, each pouring out winds and light, each tugging at its neighbors with invisible force. In such a place, collisions are common, and the debris of planet-making is thrown outward like sparks from a fire. It may have been one such spark, small, unremarkable, but set on a course that would lead far from its home. Over millions of years, encounters with other bodies shaped its path. A near pass with a massive planet could have bent its orbit, giving it more speed, more distance from its star. Another encounter might have tilted its angle, sending it out of the crowded plane where most planets travel. Eventually, one final nudge could have been enough to push it over the edge, beyond the reach of its star's gravity, into the open interstellar sea. Here, in this deep space between stars, it would meet no warmth, no light strong enough to cast a shadow. Its surface would cool until even the hardest ice was locked in place, crystalline and unmoving. Radiation from distant suns and the galaxy itself would slowly alter its skin, turning it darker over eons. Micrometeoroids, tiny fragments of rock and metal, would strike it, each collision wearing away the sharpness of its features. This is the slow erosion of the interstellar drift, where change is measured in millions of years. There is a strange balance to this environment. Nothing is there to shelter it, but nothing is there to destroy it quickly either. It can wander for ages without shattering, without burning, without dissolving into dust. It is both fragile and enduring, a relic of its own beginning, preserved by the same emptiness that isolates it. You might think of the galaxy as a forest, with each star a tree. Between the trunks lies open ground, not barren, but filled with the slow drift of seeds, leaves, and fallen branches carried by the wind. This object is one of those drifting pieces, carried not by air, but by the invisible currents of gravity. From time to time, one of these fragments passes close enough to another star to be pulled inward. Most will pass at a distance, bending slightly before continuing on. But some, like this one, will fall deep enough to touch the warmth of a new sun. The journey is not direct. It may take millions more years from the first tug of gravity to the moment when it crosses into a star's planetary system. In that time, it continues to turn slowly, its spin unchanging except for the smallest influences. Light from the galaxy glances off it, too weak to warm it, but enough to glint on the smoother surfaces. Its darker regions remain invisible in that faint glow, holding whatever secrets they have carried since their formation. Every mark upon it is a fragment of history. A shallow pit may tell of a collision with a smaller body in its first billion years. A patch of darkened material may tell of long exposure to high-energy particles. The gentle tumbling of its rotation might be the result of a glancing blow. Millions of years ago, each feature is a word in a language you can only partly read, a language written by impacts, radiation, and time. And through all of this, it remains indifferent. It does not choose its course, does not seek the sun, does not resist the pull that draws it in. It moves as everything in the universe moves, in response to forces too large and too steady to be felt in a single moment. Now, after perhaps hundreds of millions of years, it approaches a place where the faint light of the sun is stronger than any other. The boundary of the heliosphere, the great bubble of charged particles streaming outward from the sun, is far behind it now, within this region, the river of space grows warmer, more crowded, filled with the dust and plasma of the solar wind. Here, the object's long drift begins to take on a new character. It will feel the subtle pull of planets long before it reaches them. Jupiter, in particular, is a powerful presence, a giant whose gravity can alter the course of a comet, or fling it entirely out of the system. Whether this object will pass near Jupiter or remain far from it is still uncertain. But even a distant encounter could shape the rest of its journey, bending its path before it leaves again. You might picture its arrival as the quiet entry of a boat into a harbor after crossing a vast ocean. The waters are not calmer here. The gravitational currents swirl more tightly, but they are familiar to us, mapped and measured over centuries of observation. Yet for the traveler, there is no awareness of this change. It simply continues, drifting toward the light, carrying with it the marks of its long voyage. The drift itself is a reminder of scale. In human life, even a long journey can be measured in days or years. For this object, a single turnaround, its own axis might take hours, but its journey between stars has taken longer than the age of the first forests on Earth. It has seen the galaxy turn. 4 stars do not remain fixed in place, but orbit the galactic center like planets around a sun. In its time adrift, entire constellations have shifted. Entire species have risen and vanished on distant worlds. Now it nears the part of its journey that will bring it briefly into focus for us. Telescopes will follow it, measuring its light, charting its course, seeking every scrap of information that can be gathered before it leaves again. For a short time, it will be more than a drifting stone. It will be a point of connection between one star's history and another's present. And then, as always, it will move on. The long interstellar drift will not end here. After it passes the sun, it will continue outward, crossing the invisible line where the solar wind fades and the interstellar medium takes over once more. It will return to the slow river, carrying with it whatever new marks and motions this brief visit has given it. You are left with the thought that, right now, countless other objects are in the midst of such journeys. Some are leaving their home, stars. Some are halfway between. Some are already approaching new suns, unnoticed until the moment they cross into the reach of alien eyes. This one is only special because we have seen it, because our brief overlap in time and space allows us to witness it before it is gone. There is a language in the sky, but it is not written in letters or spoken in sound. It is written in motion, in the way an object curves, in how quickly it moves, in where it appears against the tapestry of stars. If you learn to read it, the sky will tell you where something has been and where it is going. Astronomy begins with watching. It starts when your eyes, or a telescope's lens, fix on a point of light and follow it across nights, across weeks, across seasons. The background stars stay still in their patterns, but this point shifts slightly, each night in a way that is neither random nor still. You note its position again and again until a path begins to emerge. This path is the first clue. Our solar system has its own family of paths. The planets follow broad ellipses, sweeping slowly around the sun. Comets and asteroids trace more elongated loops, but they, too, remain tethered, bound by the sun's gravity. These loops close in on themselves. They repeat. Anything that is born here or has lived here long enough will move in one of these closed shapes. But the visitor you watch now does not. Its path is open, not a loop, but a long, stretching curve. It will not circle back. Instead, it cuts through the solar system like a line drawn across a map, entering from one side, departing from another. Such a path has a name in orbital mechanics: hyperbolic. It means the object is traveling too fast for the sun to keep it. Velocity is the second clue. Every object has a certain speed it must stay below if it is to remain bound to the sun. Even far out, beyond Neptune, that speed limit still exists, set by the sun's distant but persistent pull. Comets from the Kuiper belt or the Oort cloud approach the sun slowly at first, only gaining speed as they fall inward. But even at their fastest, they do not outrun the limits of the sun's grasp. This visitor already exceeds those limits. Even before it feels the sun's warmth, it is moving faster than any long-term resident of the solar system. The numbers, so simple when written, speak volumes to those who know how to read them. They say, this object began its journey elsewhere. Its direction is the third clue. Most objects born here move roughly in the same plane, the thin, flat disk in which the planets orbit. This visitor approaches from an angle that ignores that plane entirely. It is not part of the slow swirl of the sun's family. It is an intruder from a different neighborhood of the galaxy. These three clues, the shape of its path, its speed, its direction, tell a consistent story. It is not ours, it never was. And when it leaves, it will not return. You can imagine tracing its trajectory backward through space. The line would pass through the Kuiper belt without touching it, skim above the Oort cloud without slowing. It would keep going, past the faint reach of the sun's gravity, into the open galaxy. Eventually, the line would dissolve into uncertainty, because small errors in measurement grow with distance. You would lose the exact origin, but not the truth. It came from far beyond the sun's domain. This is how astronomers knew that Oumuamua, the first confirmed interstellar object we saw, was not from here. The data then, as now, was clear. The sun could not hold it, because the sun had never held it. The same method, the same quiet reading of motion, reveals the nature of this new arrival. It is a process both simple and profound. The tools are numbers, but the act is something like listening, not with ears, but with attention. You wait, you let the object move, you compare one night's position to the next. The changes, subtle at first, accumulate until the story is unmistakable. There is a kind of intimacy in this. To track an object across the sky is to share in its journey, however briefly. Each observation is a point in a shared record, a sign that you have witnessed its presence on this side of its long path. And yet, the very act of measuring reveals that it will not stay. Knowing it isn't ours changes how you think of it. Comet from the Oort cloud might be interesting, even beautiful, but it is still part of the solar system's own cycle. It will leave and return, and its story will remain tied to our sun. An interstellar object is different. It is not part of our cycle. It is a brief intersection, the crossing of two long separate stories. And it reminds you that the galaxy is full of such crossings. At any given moment, there may be dozens of interstellar objects passing unnoticed through our system. We see only the brightest, the biggest, the ones that pass close enough to catch our instrument's attention. The rest remain unrecorded, their paths and origins unknown. This is why each confirmed interstellar visitor matters. They are rare opportunities to study material from another star without leaving our own. They are pieces of distant worlds that have come to us, not through intention, but through the long, slow accidents of gravity. And so you watch, knowing that what you are seeing is not truly part of your own system's history. It is something foreign, carrying the memory of a place you have never been and may never know. Its time here will be short. The sun's pull will bend its path, but not enough to keep it. Already, the mathematics of its motion predict its eventual departure, back into the interstellar dark. The moment you know it isn't ours is the moment you begin to understand its significance. It is a traveler, not one of many like it in our own neighborhood, but one of countless such travelers across the galaxy. Its presence is proof that stars share more than light. They share their debris, trading stones and ice across the gulfs of space. You think of how long it has been since this object last felt the gravity of its home star. Perhaps that star has moved on, drifting in its own orbit around the galaxy, no longer anywhere near the place where the object was first flung free. Perhaps that star has changed, cooled, dimmed, or even died while the object was still mid-journey. By the time it reaches us, its origin may no longer exist as it once did. This, too, is part of the quiet lesson it brings. The galaxy is in motion, and the distances are so vast that by the time a traveler arrives, the place it came from may be entirely different. What we see, then, is not just a messenger from another system, but a messenger from another time. There are moments in science when everything changes, not because an answer is found, but because a question refuses to fade. Oumuamua was one of those moments, a faint, fast-moving object that entered our solar system in 2017 and was gone before we could truly know it. It passed quickly, but it left a mark that remains. Before Oumuamua, the idea of detecting an object from another star was something you might consider in the abstract, possible but improbable in a human lifetime. We knew such travelers must exist. Stars trade debris over the eons. The galaxy is filled with wanderers, but finding one was like waiting for a single leaf to drift past on an endless river, a leaf that might only be in sight for a moment before it is gone. And then, without warning, that moment came. It appeared first as a faint point of light in a survey telescope's images. just another moving speck among many. But its speed, its steep path, and its direction revealed it almost immediately for what it was. The first confirmed interstellar object ever observed passing through our solar system. It even earned a name that carried a sense of its journey: Oumuamua, Hawaiian for scout or messenger from afar. The lessons it brought began with surprise. We expected an interstellar visitor to look like a comet, icy, brightening as it approached the sun, trailing gas and dust. Instead, Oumuamua looked inert. No visible tail, no haze of gas. It was a small, dim, elongated object, its light flickering as it tumbled through space. That flicker held the second lesson. By measuring the changes in its brightness, astronomers realized it was far more stretched out than any asteroid or comet we had seen before. Its length could have been up to 10 times its width, more like a shard than a sphere. This strange shape hinted at an unusual history. Perhaps it was a fragment of a larger body, broken by some violent event long before it entered our skies. The third lesson came from its motion. As it left the inner solar system, it accelerated, in a way that could not be explained by gravity alone. For a comet, such acceleration can be caused by jets of gas escaping from warming ice. But we saw no such jets. No visible evidence of venting. It was as if Oumuamua had been given a gentle push from an invisible hand. That mystery is still unsolved. Some explanations are simple. Maybe it was venting in a way too subtle for our instruments to detect. Or perhaps its surface contained unusual ices that sublimated without producing visible dust. Others are more exotic, but the truth remains hidden, locked in the silence of a traveler that will never return. The final, and perhaps most important lesson of Oumuamua was urgency. Its speed meant we had only weeks to study it before it became too faint to track. By the time we understood its uniqueness, it was already receding into the dark. We learned that when the next visitor comes, we must be ready, telescopes prepared, questions sharpened, instruments tuned for the brief opportunity. And so, astronomers have been watching. Wide-field surveys now scan the sky every night, searching for fast-moving points of light that might reveal another interstellar traveler. When this new object appeared, it was noticed quickly. Its hyperbolic path was recognized almost immediately. The readiness that Oumuamua inspired is the reason we are talking about this visitor at all. You think of how Oumuamua's story changed the way we imagine the space between stars. Before, that space felt more like a gap, a separation. After, it felt like a bridge, not an easy one to cross, but one that is crossed more often than we once believed. The emptiness between suns is threaded with slow, drifting messengers, each carrying fragments of their distant birthplaces. In the years since, debates about Oumuamua have continued. Was it a fragment of rock and ice? Was it rich in hydrogen? Ice that evaporated invisibly? Was it something entirely new to science? The truth may never be certain, but the act of asking, of testing possibilities against the evidence, has deepened our understanding of what is possible. It also reshaped our expectations. We now know that an interstellar object might not look like anything in our own solar system. It might be elongated, tumbling, unusually reflective, or strangely inert. It might brighten in unexpected ways, or not at all. It might follow rules we know, or hint at rules we have yet to learn. This is the quiet gift of Oumuamua. It opened the door to surprise. It taught us to expect that what arrives from another star will carry not just matter, but mystery, and mystery in science is not a problem to be avoided. It is the beginning of discovery. You picture the long arc of this readiness. The next visitor after Oumuamua could be decades away, or it could appear tomorrow. It could be larger, giving us more time to study it, or smaller, slipping past before we can react. It could pass close to Earth, or stay far beyond the reach of any spacecraft we could send. The uncertainty is part of the patience, the same patience the object itself has shown on its long journey to reach us. And now, here it is, another traveler, different in shape, in brightness, perhaps in origin, but part of the same story, the story of stones cast between stars, carrying with them the quiet weight of their history. When you look at it through the lens of Oumuamua's lessons, you see more clearly what matters. You know to measure its brightness often, to track how it changes with rotation. You know to study its color, its spectrum, for hints of ice or minerals. You know to calculate its path precisely, so you can see how gravity bends it and weather. It moves in ways gravity alone cannot explain. There is also a deeper, less technical lesson, one about attention. In a universe where events play out over millions of years, the moments when we can witness them directly are rare. To be alive, here and now, when such a visitor arrives, is to be part of something both fleeting and immense. It is a reminder that you do not just live in the solar system. You live in a galaxy that sometimes sends you messages in the form of silent, drifting stones. Oumuamua was the first message we noticed. This is the second, and there will be more. The first images arrive not as photographs you could hold in your hand, but as arrangements of numbers. Each value represents the faintest breath of light, captured by a detector peering through the restless shimmer of Earth's atmosphere. This is how you see something that would otherwise be invisible. You gather what little it gives, one photon at a time, and piece it together in patience. The result, at first, is almost nothing. A dim point against the deeper black, no sharper than the blur of a distant star. But you know it moves. You know that if you collect enough images over enough hours, the point will shift. It is that shift, repeated again and again, that will let you follow it through space. The light you receive has traveled for minutes from the sun to the object, and then for more minutes from the object to the telescope. But in another sense, it has traveled much longer. It has spent millions of years in darkness, waiting for a star to come close enough for it to reflect that star's light. Only now, after all that waiting, does it return the sun's glow toward your eyes. As more observations are taken, patterns begin to emerge. The brightness does not remain constant. It rises and falls, sometimes subtly, sometimes sharply, over the course of hours. This is the rhythm of its rotation. When a larger face turns toward you, more light is reflected. When a narrower edge or darker surface is turned your way, the light dims. From these fluctuations, you begin to sketch its shape, not with lines on paper, but with measurements and probabilities. Perhaps it is elongated, like a stone worn into a spindle by ancient forces. Perhaps it is irregular, a fragment torn from a larger body. Its light curve, the rise and fall of brightness, is the only clue, and it must be read carefully. Like a letter written in a language you do not fully speak, you also read its color. Though here color is not the simple red or blue, your eyes know. Instead, you measure its brightness through different filters, each allowing only certain wavelengths to pass. A slightly redder tint might mean iron-rich minerals or a surface darkened by cosmic rays. A bluer tone could hint at fresh ice, perhaps recently exposed by a collision or by a these hints, too, are fragments of its history. The surface itself is unknowable at this distance, but the way it reflects light speaks of texture. A smooth, icy sheet would reflect more directly, flashing bright at certain angles. A rough, dusty covering would scatter light in all directions, producing a softer, steadier glow. You see no sudden bursts of brightness, no sharp glitter. Perhaps it is dusted with the fine debris of micrometeor impacts, giving it a muted sheen. The faintness of the object demands the best of our instruments. Even the largest telescopes, with mirrors that gather as much light as possible, struggle to bring it into clarity. Between you and it, the atmosphere ripples with turbulence, blurring the details. Some observatories use adaptive optics to correct for this, reshaping mirrors in real time to sharpen the view. Others rise above the air entirely, orbiting in space where the light arrives unbent and undisturbed. Yet, even in the cleanest image, it is no more than a dot. The story is not told in what you see directly, but in what you can infer. Astronomy is often like this. The beauty is in the deduction, the transformation of raw light into understanding. Each observation becomes part of a model, and the model grows richer with time. You feed it, the timing of the brightness changes, the range of colors, the exact position of the object in the sky each night. The model begins to predict what you will see in the next observation, and you compare prediction to reality. When they match, confidence grows. When they do not, the model changes, and in that change, you find something new to learn. This is how the object slowly gains form in your mind. Not a photograph pinned to a wall, but a portrait assembled from clues, a rotation period, a likely shape, a hint of surface color, a range of possible sizes. Each clue narrows the possibilities, but the picture never becomes complete. There is always uncertainty, always the awareness that what you believe may shift with the next fragment of data. The light itself is not pure. It carries the imprint of the sun, since it is the sun's light reflected back to you. Hidden in that reflection are subtle shifts caused by the object's own motion, a slight stretching or squeezing of the wavelengths. The Doppler effect tells you how fast it is moving toward or away from you. Combined with the motion you see across the sky, this reveals the full three-dimensional path it takes through space. When you think about it, this portrait is more than just a picture of what it looks like now. It is also a record of how it moves, how it turns, and how it interacts with light. It is both a physical and a temporal image, a map of now, but also of the next hours and days. And yet, you feel the limitations of the view. You cannot see the fine cracks in its surface, the tiny craters where micrometeorites have struck. You cannot see if it has ridges or planes, if it is fractured or whole. You can only see the sum of its light, averaged over its spin, smoothed by distance. The portrait you hold is both precise and incomplete. You reflect on how much of astronomy is like this, painting the unseen with the faintest brushstrokes of data. The patience required is its own kind of reward. Each night's work is not a finished picture, but another thread in a tapestry you may never see in full. Still, the longer you watch, the more the object reveals itself in small ways. The rotation period becomes clearer. The shape, once uncertain, settles into a likely form. The variations in brightness narrow into a pattern you can predict. The portrait sharpens, not in the way of a sudden revelation, but in the way a dawn slowly brightens a landscape. And then there is the awareness that the light you are measuring is old, not ancient in the way of starlight that travels for centuries, but still delayed, minutes old when it reaches you. By the time you record it, the object has already turned a little more, moved a little farther. You are always seeing it as it was, not as it is. Perhaps that is why the portrait feels almost like a memory, a collection of moments that are already past, stitched together into a present you can hold in thought. It reminds you that in the cosmos, observation is always a form of looking back. Now, as the days pass, the portrait grows fuller. It is still faint, still blurred by distance, but it is no longer anonymous. It has a rhythm, a color, a probable size and shape. It is not just a point of light anymore. It is a thing with identity, however incomplete your knowledge of it may be. You think of how, in a way, every celestial portrait is a collaboration. The object sends its light, the instruments receive it, you interpret it. None of these steps alone would give meaning. Only together do they create the fragile bridge of understanding between a distant traveler and your small, waiting world. And though the portrait will never be perfect, it is enough to know that it exists, that in the vastness of space, a stranger has been noticed, measured, and given shape in human thought. It will leave, as all such visitors do, but this record will remain, a quiet testament to the meeting of light and attention. Every object in space turns. Sometimes the spin is quick, like the flick of a tossed pebble. Sometimes it is slow, like a leaf turning gently in a breeze. But always there is rotation, the quiet turning of a body that carries with it the history of everything that has ever touched it. Spin is memory. It is the leftover motion from the forces that shaped an object's life. A collision long ago might have set it twirling, the speed and direction determined by the angle of the strike. A close pass with a planet could have altered that motion, pulling on one side more than the other, leaving it rotating in a new way. Each event leaves an imprint, and though the surface may change, the spin endures. The object now in the sun's realm turns with a rhythm you cannot see directly, but can feel in the rise and fall of its light. As it spins, its brightest face comes into view, then fades, then returns. This repeating pattern, the light curve, is your way of sensing its rotation from across millions of kilometers. You measure this flicker patiently, a peak in brightness. Here, a dip there, recorded night after night. Soon the intervals begin to repeat, revealing the length of its day. For some objects, a day may be just a few hours long. For others, it can last many Earth days, the slow turns stretching across the length of an entire week. But spin is not always simple. Many objects do not rotate smoothly, like a planet with a steady axis. Instead, they tumble, turning around more than one axis at once. This kind of motion is called complex rotation, and it can result from a violent past, a collision that jolted the body so strongly that it never settled back into a single calm spin. Such motion means the light curve is more intricate, the brightness changes, less predictable. If you could stand close to the object, you would see how rotation changes the way sunlight touches it. Surfaces move in and out of shadow. Crags and ridges catch light for moments before turning away. Dark regions spend long hours in cold, while bright slopes warm briefly before fading back into the shade. The whole body moves like a slow, ancient clock whose hands are jagged and uneven. The rate of spin can also tell you something about the object's structure. A very fast spin might mean it is solid through and through, able to hold itself together under the pull of its own motion. If it were loose rubble, too much speed would tear it apart. A slow spin, on the other hand, might mean it is made of loosely bound material, turning gently so it does not scatter itself into fragments. Some objects change their spin over time, even without collisions. This can happen when sunlight warms one side more than the other. As the heated surface releases that energy back into space, it produces a faint, uneven push, too small to feel in a moment, but enough to gradually speed up or slow down the rotation over millions of years. It is as though light itself can whisper to an object, altering its rhythm across ages. The direction of spin is another clue. Most bodies in a planetary system tend to rotate in the same general direction as their orbits, a relic of the swirling disk of gas and dust they formed from. But an interstellar object may carry a rotation entirely unrelated to the Sun's system. Its axis tilted at any angle, its spin direction set by events far away long ago. You realize that to study spin is to study memory in motion. It is one of the few records the object carries that cannot be erased by surface weathering or erosion. The surface may be scarred, dusted, or altered, but deep within, the inertia of its rotation remains, holding the imprint of its earliest encounters. From Earth, the process of learning this spin is an act of patience. Night after night, the object grows fainter as it moves farther from the sun, and the flicker in its brightness becomes harder to measure. But every data point matters. Even incomplete curves can be stitched together to reveal the pattern beneath. The numbers you collect do not just describe how the object turns now, they allow you to imagine how it has turned for centuries, perhaps millennia. Unless a strong force acts upon it, that rhythm will remain almost unchanged for ages to come, carrying the memory of its formation into whatever distant future it will see. And so, in studying its spin, you are listening to a story told not in words, but in motion. It is the story of a body shaped by gravity and chance, turning alone in the dark, carrying the echo of every force that has ever touched it. The thought brings a kind of quiet humility. From here, on your warm, spinning planet, you measure the turn of something that has crossed the gulf between stars. It will never know you, never sense that it has been observed. Yet its movement has crossed the threshold of human awareness. The spin is constant, but your time to watch it is not. The object moves on, growing dimmer, the pattern harder to see. Eventually, you will lose it, and its rotation will continue beyond your sight. But for now, you hold this piece of its story. A memory written not on its surface, but in its motion. Between the stars lies a darkness that seems empty, but is not. It is a slow, patient wilderness, filled with materials that drift without end. You cannot see them with the naked eye, the grains of dust, the lumps of ice, the shards of rock. They move quietly through the void, shaped by forces so gentle and so long-lived that human time barely touches them. Some of this material was made in the cores of ancient stars, forged under pressures so immense that atoms were bound into new forms. When those stars died, they scattered their enriched matter into space, a cloud of heavy elements and complex molecules free to wander. Other material came from the quiet erosion of planets and moons, chipped away by impacts, peeled away by heat, or stripped by the touch of stellar winds. The interstellar medium, the space between suns, is a patchwork of these origins. It holds clouds of hydrogen gas, so thin you could travel for years without brushing more than a handful of atoms. It holds icy wanderers the size of mountains, holding in their frozen interiors the chemistry of their birthplaces. It holds fine dust older than the planets, older even than our own sun. Dust that has floated through the galaxy for billions of years without ever falling into the gravity of a star. The object you watch now is one such wanderer. It has drifted through this wilderness for perhaps hundreds of millions of years. Its surface has been darkened by radiation, high-energy particles streaming from supernova, from active stars, from the very structure of the galaxy itself. These particles have struck it again and again, breaking chemical bonds, rearranging molecules, leaving behind a skin of altered material. Beneath that outer layer, though, the original matter remains. Here, ice might still preserve ancient chemistry, untouched since the day it was locked away. That ice could hold simple molecules, water, carbon dioxide, methane, or more complex ones, like amino acids, the building blocks of proteins. Such molecules are not rare in the galaxy. They have been found in comets in our own system, and in the gas and dust between stars. The cold is their ally. In temperatures near absolute zero, reactions slow to a near halt, and fragile structures can survive for eons. The rocks, too, carry stories. Some may be volcanic in origin, fragments from a world with flowing lava and a crust that cracked under stress. Others may have been born in impacts, shrapnel from collisions between asteroids or planets flung outward into space. Still others could be metamorphic, shaped by pressures and temperatures deep within a world's crust, then exposed and ejected into the dark. The minerals in these rocks can reveal the conditions of their birth. A crystalline structure might hint at slow cooling in a sheltered environment, perhaps beneath a planet's surface. Glass-like textures might speak of sudden melting and freezing, the kind that happens in violent impacts. Metals might suggest a history near the core of a differentiated world where heavy elements had sunk inward under gravity. Even the dust clinging to the object's surface has a history. It may be made of silicate grains from the debris of a long-dead star. It may hold traces of carbon-rich compounds formed in the outer shells of red giant stars. Some of it may have been collected during the object's long drift, sticking to its surface after gentle collisions in the slow-moving lanes of interstellar space. When you think about it, this object is a sampler, a small physical collection of matter from a place you cannot yet visit. Its chemistry was set by the star it once orbited, its minerals by the worlds that shared that system, its surface by the deep time it spent between suns. To study it is to open a kind of time capsule, one delivered not by design, but by the quiet mechanics of the galaxy. But the challenge lies in distance. From here, you cannot scoop a sample or run it through a laboratory. You can only read its composition from the sunlight it reflects, or from the faint heat it emits. Spectroscopy becomes your tool, splitting the light into its component wavelengths, searching for the subtle fingerprints left by different materials. A dip in the spectrum might mean water ice. A slight bump could suggest complex organics. The presence of certain metals could hint at its parent world's geology. But the signals are faint, mixed, and altered by the journey. Radiation may have changed the outer layers so much that they hide what lies beneath. Still, even a few confirmed ingredients would be precious. If you find organics, you can begin to ask whether they formed in the warmth of a planetary surface, in the cold of interstellar space, or in the glow of a distant star. If you find unusual minerals, you can start to piece together the kind of world that birthed them. Every hint pulls the distant origin a little closer, and you cannot help but think of the possibility that some of this material might have once been part of a living world, not necessarily carrying life itself, but shaped in the presence of it. perhaps altered by the atmosphere of a living planet, or touched by the chemistry of a biosphere. That thought is not a conclusion, only a reminder that life and matter are deeply linked, and that the galaxy's exchange of material could also be an exchange of potential. The material between suns is not static, it moves with the rotation of the galaxy, following the great spiral arms, gathering into clouds and dispersing again. Stars are born from these clouds, planets from the dust and ice that surrounds them. Some of that matter will remain bound to its new home. Some will be flung outward again, starting the cycle over. The visitor you see now is part of that cycle. It has left one home and will pass through another before returning to the deep. It is not unique in this role. There may be millions like it, unseen, but it is rare in that you can see it, measure it, and think about what it carries. It is a reminder that the space between stars is not a gap, but a highway. Matter flows along it, slowly and silently, linking places you will never visit in person. Your world is not separate from this network. Earth itself contains atoms that were once part of other stars, other systems, other times. As you watch the object drift inward, you think of its surface holding a record of all these journeys, a darkened crust, a frozen core, a mixture of dust from places scattered across the galaxy. To touch it would be to touch something that has traveled through 1 billion years of history, and yet soon it will be gone from sight. Its secrets will remain locked away, unless one day a spacecraft could follow it into the dark. For now, all you have is the faint light it reflects, and the knowledge that it carries, a fragment of another home. Every traveler carries its past on its surface, not in letters or carvings, but in the slow, patient marks left by time and motion. Here, in the cold of space, there are no oceans to wash away a scar, no winds to smooth the edges. What happens here is remembered for millions of years. The object before you wears its history like a weathered skin. You cannot see it in perfect detail from this distance, but the patterns of light and shadow hint at a surface that is uneven, varied, and complex. Some regions reflect more sunlight, others swallow it into darkness. These differences are not random. They are the echoes of ancient events. Impacts are one of the most common sculptors in the cosmos. Tiny grains of dust, traveling at speeds faster than any bullet, strike with enough energy to chip away at rock and ice. Larger fragments can gouge deep craters, sending shards into space and reshaping the terrain. In the vacuum, these scars do not erode away. They remain as records, each one a frozen moment from a distant time. The small pits that pepper the surface may be the oldest marks of all. They could have formed during the object's earliest days, when it still orbited its parent star in a crowded region full of other newborn bodies. In that era, collisions were frequent, and survival meant learning to endure a constant hail of impacts. Some marks may come from later, as it wandered between suns, passing through thin clouds of interstellar dust that sandblasted its skin over millions of years. Radiation, too, leaves its mark. High-energy particles from stars and the galaxy strike the surface again and again, breaking chemical bonds, changing colors, darkening once bright ice into deep browns or reds. This is space weathering, not a storm of wind and rain, but a storm of particles and light. The changes happen slowly, but over time they can turn an object's surface into a hardened altered shell. Sometimes the past is revealed in fractures. Cracks may run across the terrain, evidence of stress from impacts or from heating and cooling. As the object turns, One side warms slightly in the sun's light, while the other remains in shadow. The materials expand and contract, creating tiny stresses that, over millions of years, can break rock apart. In a place with no air, no water, and no life, even this slow breathing of heat and cold can shape the land. There may be smooth regions as well, places where fresh material has been exposed more recently. A landslide on a low-gravity slope could reveal brighter ice beneath the darker crust. A recent impact could scatter fine particles across a crater floor, softening its features. Even in the stillness of space, there are moments of sudden change, and those moments leave visible traces. Some of the most intriguing marks are subtle, faint streaks, patches of unusual color, or areas that reflect light differently than their surroundings. These might be signs of materials that migrated across the surface, carried by sublimating ice or by the gentle pull of gravity toward low points. They could be relics of the object's time near another star, when heat reshaped its outer layers. Before it was flung away, as you look at it, you realize that reading such a surface is like reading a book whose pages are scattered and incomplete. You have the marks, but not the order in which they were made. You can guess at the causes, but you cannot know the exact moment or the full story. And yet, even fragments tell you more than you knew before. You imagine a time when it was part of a larger body, perhaps a moon or an asteroid orbiting another star. A collision could have shattered that world, sending fragments into space, each carrying a different record of the same violent moment. Over time, each piece would collect its own new history, layering it over the old. The surface you see now is the sum of all those layers, a palimpsest written over again and again by the events of deep time. Even the absence of certain marks can speak volumes. If a region is unusually smooth and unscarred, it might mean that it has been resurfaced recently, perhaps by ice shifting beneath the crust or by the gentle flow of loose material in the weak. Gravity, in the cold and quiet of space, recent can mean anything from a few million years to a few 100,000. You think of the object's journey between stars, how it must have passed through regions filled with debris and others so empty that nothing touched it for millions of years. The scars are not evenly spaced in time, but clustered, reflecting these alternating epochs of violence and peace. Light itself helps to reveal these details. When the sun strikes at a shallow angle, shadows grow longer, emphasizing ridges, pits, and cracks. When it shines directly overhead, the surface looks flatter, hiding some of its texture. By watching it over time, as the object rotates, you gather different views, piecing them together into a more complete sense of its shape and condition. You know that in a perfect world, you could send a probe to skim its surface, to photograph every detail, to collect samples of its dust and ice. But for now, you must work with the clues that light offers from afar. Each flicker, each change in brightness, becomes part of your mental map of its terrain. What you see is not just a set of features, it is a record of endurance. This traveler has survived collisions that could have shattered it, radiation that could have eroded it, and the endless cold that could have fractured it into dust. It remains whole enough to reach you, still turning in the sunlight, still carrying the signs of every storm it has endured. You wonder how much longer it will keep those marks, when it leaves the sun's warmth and returns to the deep cold between stars. Its surface will change again, slowly and invisibly. Micrometeoroids will strike, dust will accumulate, radiation will continue its patient work. The marks you see now will fade into new ones, and this chapter of its history will be covered by another, For now, though, you see it as it is, a messenger with a skin of stone and ice, each scar a word in a language older than life on Earth. It does not tell you everything, but it tells you enough to feel the weight of its journey. In space, greetings are not spoken. They are exchanged through the quiet language of gravity, a language so constant and subtle that you only notice it when you step back and watch the path of things. It is through this language that the solar system first welcomes its visitor, long before human eyes detect it. The sun's influence is already at work. Its pull has been felt for months, perhaps years, bending the traveler's trajectory ever so slightly toward the heart of the system. The closer it comes, the more this pull grows, until its path is no longer straight but curved, a slow arc inviting it inward. Yet the sun is not the only greeter here. The planets extend their own reach, their gravity tugging at the object even from great distances. Neptune, farthest of the giants, touches its path first, not enough to change it dramatically, but enough to nudge it into a slightly different angle. In space, even the smallest change in direction can, over millions of kilometers, shift the course entirely as it continues inward. The visitor feels the more insistent call of Saturn and then Jupiter. Jupiter's gravity is a force to be reckoned with, a vast, invisible presence that can fling comets into the far reaches of the solar system or draw them into close encounters. It acts like a great gatekeeper, its pull extending so far that it influences objects long before they come near. These gravitational touches are not sudden grabs, but gentle steering hands. The visitor does not jerk or jolt. It simply flows along a path that is constantly and invisibly adjusted. The planets do not pull equally. Their influence depends on distance, mass, and timing. But together, they create a complex pattern of forces, each one layering onto the sun's dominant pull. You might think of it as a dance floor with one great central dancer, the sun whose steps set the rhythm for everyone else. Around it move the planets, each with their own steps, each casting a subtle influence on the others. When a stranger steps onto the floor, they are swept into this choreography, not by invitation in words, but by the irresistible tide of motion. Sometimes, these encounters are brief and distant. Sometimes they are close and transformative. A near pass by a massive planet can dramatically change an object's speed and direction. A gravitational slingshot. This effect can fling the traveler out of the system faster than it came in, or slow it enough that it lingers for a time before departing. For this visitor, the path is already set to carry it through without capture. Its speed, even before it felt the first tugs of the planets, was greater than the sun's gravity could bind. Still, the planets will leave their fingerprints, small shifts in trajectory, tiny changes in velocity, adjustments that will ripple through the rest of its journey. Even the smaller worlds, Mars, Earth, Venus, have their role, though their influence is faint compared to the giants. If the visitor's path brings it close enough, these worlds can also bend its course or scatter particles from its surface with the pressure of sunlight reflected from their clouds. Every encounter, no matter how small, is part of the ongoing exchange between bodies in space. What makes this greeting so remarkable is that it is inevitable. The visitor does not choose to be influenced. The planets do not choose to exert their pull. It is simply the way of things. Mass attracts mass, and the shape of space is bent wherever matter resides. In this way, the solar system does not just passively exist. It actively shapes the journeys of all who pass through. The gravitational reach of Jupiter in particular, has been both a guardian and a gatekeeper for our system. It has deflected many incoming comets that might otherwise have crossed paths with Earth. It has also redirected countless bodies into orbits that bring them into the inner system, some becoming regular visitors over thousands of years. For this traveler, Jupiter's role will likely be to bend the path just enough to alter the course it will take when it leaves. You imagine the traveler's view, though it has no eyes, no awareness of the sun growing brighter with each passing day, the planets gliding along their own paths, each one an island of mass and motion. From far away, the gravitational pull of each world is indistinguishable from the overall current of the sun's influence. But up close, these pulls become more personal, more directional, capable of shaping the finer details of the path. Even the belts and clouds of smaller bodies, the asteroid belt between Mars and Jupiter, the Kuiper belt beyond Neptune, contribute in their way. Individually, these objects are too small to matter much, but collectively, they make up a subtle background of gravity, like the texture beneath the main currents. And through all of this, the visitor continues inward, its speed increasing under the sun's pull. It does not resist. In the silence of space, motion is not something to be overcome. It is simply the state of being. You realize that this greeting is not just about gravity. It is about connection. The planets cannot help but alter the path of something that comes close. The traveler cannot help but be altered. In this way, every visitor leaves a trace of itself behind, and every system leaves a trace upon the visitor. Soon, the path will bring it into the region where Earth and its neighbors move. From here, the gravitational interactions will be more subtle, but the observations will be sharper. Telescopes will follow it closely, and its movement across the background stars will be measured with exquisite precision. These measurements will not only describe its present path, but also reveal how the earlier touches of Jupiter, Saturn, and Neptune have already shaped it. And when it leaves, those influences will still be there, embedded in its new trajectory, carrying the marks of this encounter into the vastness between stars. It will carry no memory in the conscious sense, but its future path will be the sum of all the pulls and nudges it experienced here. The solar system's greeting, then, is not like a handshake you can release. It is a permanent exchange, written into the mathematics of the object's motion. From this point on, its journey will forever bear the fingerprints of our sun and its planets. Life, as you know it, is fragile, dependent on warmth, water, and chemistry in balance. Yet life's ingredients are anything but fragile. The building blocks can endure in the cold, in the dark, drifting for millions of years. In the vastness between stars, they may sleep for eons, waiting only for the right shore to wash upon. The thought is not new. For decades, scientists have wondered if life, or at least the ingredients of life, could travel between worlds, carried by natural messengers like this visitor. The idea is called panspermia, a word that means seeds, everywhere. In this picture, the galaxy is not a scattered collection of isolated gardens, but a field where seeds ride on the winds of space. Those seeds might be tiny grains of organic rich dust, small enough to be shielded inside rock or ice. Within them could be simple molecules, like amino acids, the letters from which proteins are written. These molecules form readily in many environments, in the chemistry of a planet's surface, in the frozen shells of comets, even in the clouds of gas. Between stars, what they need most is protection, a way to survive the radiation and the cold until they reach a place where they can react again. A body like the one drifting toward our sun could provide that shelter. Its outer layers may be hardened by radiation, forming a crust that shields the ice beneath. Inside that ice could be complex organics, preserved since the object left its home system. Perhaps those molecules formed on a distant world warmed by another star. Perhaps they formed in the cold of interstellar space, where ultraviolet light from nearby stars powered the chemistry on their icy surfaces. If life existed in the object's home system, it is conceivable, though uncertain, that traces of it could be frozen within. Microbes, if hardy enough, could be locked in suspended animation inside ice or rock. On Earth, life has been found surviving in extremes, in boiling vents at the bottom of the sea, in ice more than 1 million years old, in the dry and frigid soil of Antarctica. Such examples remind you that life can be stubborn, clinging to existence in ways that defy expectation. But surviving the journey between stars is another matter. Radiation slowly breaks apart molecules, even under layers of shielding. Impacts and heating during ejection from a planetary system could destroy delicate structures. And then there is time itself. Millions or even hundreds of millions of years of drifting before another star is encountered. In that time, much can be lost. Still, not everything would vanish. Some molecules are remarkably durable. Amino acids have been found inside meteorites that fell to Earth, their structures intact after billions of years in space. Complex organics have been detected on comets, in interstellar clouds, and on the surfaces of icy moons. The chemistry of life's ingredients seems to be widespread, even if life itself is rare. This is why scientists pay close attention to such visitors. They are not just rocks or ice, they are samples from another place, delivered free of charge by the mechanics of the galaxy. Even if they carry no living cells, they may carry patterns in their chemistry that hint at the processes that shaped them. The ratio of certain isotopes, for example, can reveal the temperatures and environments in which the molecules formed. The presence of unusual compounds might suggest a history of heating, or of reactions in the presence of liquid water here on Earth. Meteorites from Mars have provided tantalizing hints of such stories. Some contain organic molecules that could have formed in the Martian environment. Others show mineral patterns consistent with having been altered by water. While none of these have been confirmed as signs of life, they demonstrate that rocks can indeed carry detailed chemical records across space. Now imagine the same principle, but on a scale far larger. An interstellar object like this one could be a messenger from a star system entirely unlike our own, perhaps one with planets closer to its star, or with moons warmed by tidal forces, or with chemistry driven by completely different conditions. Its cargo of frozen material could be unlike anything we have sampled before. Of course, to learn these things, you would need a sample. From here, across the gulf of space, you can only measure what light reveals. Spectroscopy can hint at the presence of organics, but it cannot tell you the full story of their arrangement, their complexity, or their origin. For that, you would need to touch the object to bring part of it back for study. The dream of doing so is not impossible. Spacecraft have already visited comets and asteroids in our own solar system, returning samples to Earth. The challenge with an interstellar visitor is speed. It moves too quickly for current missions to launch, catch, and return within its brief stay. Some scientists have proposed building spacecraft specifically designed to wait for such opportunities, ready to launch at a moment's notice. Perhaps one day, when the next visitor arrives, we will be ready. Until then, the question remains suspended in possibility. Could such a body carry the seeds of life? Could its chemistry tell us that life's ingredients are not unique to our world, but a part of a galactic pattern? The evidence so far is circumstantial, compelling, but incomplete. We know the building blocks are common. We know they can survive in space for long periods. We know they can be delivered to worlds by impacts. What we do not know is how often they take the final step into living systems. It is a humbling thought. Life on Earth might have been seeded, in part, by travelers from elsewhere, not in some deliberate act, but as a natural consequence of the galaxy's restless motion. If so, then life here is connected, however distantly, to life, or to the raw materials of life elsewhere. And if it happened here, it could happen again and again in other places. But humility also comes from knowing the limits of what you can prove. This visitor may hold no trace of biology at all, only chemistry frozen in time. Or it may carry molecules so altered by radiation that their origins are unreadable. Science asks for patience in such matters, and patience is something the cosmos has in abundance. Still, the possibility remains, and with it, a quiet sense of wonder. Somewhere, in the dark between stars, there are other objects like this one, each carrying their own chemical histories. Some may pass by unnoticed, their potential secrets never revealed. Others, like this traveler, will be caught in the brief gaze of human curiosity. You do not know yet what this one carries, but even without certainty, it offers you a truth worth holding, that the materials of life are not bound to one world, but are scattered, waiting, across the galaxy. There is a kind of beauty that comes only from knowing something will not last. It changes the way you look, the way you listen. Each detail becomes sharper, not because the thing itself is clearer, but because you are aware of how quickly it will fade. This is the nature of watching an interstellar visitor. It appears in the sky as a faint point of light, and already, from the moment of discovery, it is leaving. The path it travels is steep, its speed relentless. The sun's gravity bends it, but cannot hold it. Our gaze bends toward it, but cannot keep it. In the first days, it is bright enough that smaller telescopes can follow it. Photons stream into lenses and mirrors, carrying their quiet messages about its position, its brightness, its spectrum. But night by night, its light thins. What you can see with ease today will take more effort tomorrow, and soon will require the largest instruments we have. Every moment counts. The Earth's rotation gives you only a narrow window each night. When the object rises above the horizon, away from the glare of the sun, clouds, wind, or the faint glow of the moon can eat into that precious time. An entire night's opportunity can be lost to weather, and there is no rescheduling with the sky. This is why the work of observation is so deliberate. Each measurement is planned in advance, knowing that there may be no second chance. If you miss the chance to capture its spectrum under the right conditions, the data may never be collected again. If you fail to track its changing brightness, the clues about its rotation and shape will be incomplete forever. Light itself limits you. The farther the visitor travels from the sun, the less light it reflects, even as it approaches the inner system and brightens briefly. Its speed means that peak visibility is short-lived. Once it passes closest to the sun, the brightening is over, and it begins to dim faster than it brightened. Astronomy is filled with patience, but here, patience is not the virtue readiness is. The moment to act is now, in these few weeks or months when the object is within reach. It is like trying to study a snowflake as it drifts past an open window, delicate, fleeting, and impossible to recall once it is gone in this work. You become deeply aware of the fragility of knowledge. What we understand about this visitor will be drawn entirely from this brief window of observation. When it leaves, it will take with it every detail we did not have the time, skill, or technology to capture. No future telescope will see it again. Its departure is permanent. You measure time not in days or months, but in remaining nights. Each one is a chance to fill in another piece of the puzzle, to refine its path, to detect new spectral features, to confirm or challenge earlier results. Every night missed is a piece of the story that will remain forever. Unwritten, it is not just the object's departure that makes observation fragile. The tools we use to study it are not perfect. Detectors have limits. Atmospheric turbulence blurs the sharpness of the light. Calibration errors can slip in. Even with the most careful work, the record we keep is incomplete, filled with estimates and uncertainties. Yet these uncertainties are not failures. They are reminders that astronomy is an act of reaching out across impossible distances, catching whatever fragments of light you can. You never hold the whole thing in your hands. You only touch what it sends you moment by moment. Some nights the data will be rich, a sharp light curve, a clear spectral line, a perfectly timed astrometric position. Other nights will yield almost nothing, as clouds hide the target or the faintness of the light defeats the instruments. The scientist's discipline is to gather it all, knowing that even imperfect data can hold meaning when combined with the rest. In a sense, the object itself teaches you this discipline. It does not slow down or wait for you. It moves to its own timetable, shaped by forces far greater than you can influence. You must adapt to it, not the other way around. This is humility, and also the quiet joy of working in step with the rhythms of the cosmos. The fragility of observation also comes from your own limits. Human attention can waver, priorities can shift, resources can be stretched. There are other projects, other needs, other demands on the time of telescopes and researchers. Deciding what to observe and how often is always a compromise. And yet, despite all these challenges, something remarkable happens. The data grows. From scattered points of light, a trajectory takes shape. From faint color measurements, a surface composition emerges. From the gentle rise and fall of brightness, a spin period becomes clear. Piece by piece, the object stops being a nameless dot and becomes a thing with identity and story. This is why every night matters, because you do not know which measurement will be the one that reveals something unexpected. It might be the faintest spectrum, taken at the edge of the object's visibility, that hints at an unusual chemical. It might be a single brightness measurement that aligns with others to show a sudden change in rotation. The science is built on these moments, and the moments are fleeting. When you think about it this way, the act of observing becomes not just a technical process, but a kind of meditation. You become acutely present, aware of the exact moment the light from the object touches your instruments, aware that it will never pass this way again. It is the same awareness you feel when holding something delicate, knowing you cannot replace it if it breaks. One day soon, the object will be too far and too faint for even the largest telescopes to see. It will pass beyond the reach of optical light into the domain of radio silence and deep cold. When that happens, the record will close. We will know only what we managed to gather during its brief visit, and yet that record will be enough to remind us that it was here that for a short time the paths of two very different travelers, one of rock and ice, one of flesh and thought, crossed in the dark. We will remember that we looked, and that looking, even when brief, changes the way we understand our place in the universe. Every journey has its turning point, the moment when approach becomes departure. For this visitor, that moment has come. The path that once drew it inward now bends it outward again, curving away from the sun, away from the planets, away from us. The slow pull that welcomed it here is now the same pull that will let it go. You know it will not stop. Its speed is too great, its path too steep to be caught in an orbit. The sun has shaped its course, but cannot claim it. From the moment it entered the solar system, this departure was already written into its trajectory. The change is almost invisible at first. From night to night, it still appears in the same part of the sky, still reflects the same sunlight. But gradually, the angles shift. Its motion across the background, stars grows slower in our perspective, even as its true speed remains enormous. It begins to sink toward the horizon earlier each evening, moving into skies more difficult to observe. Its brightness fades too. The sunlight that once struck it so strongly now arrives weaker, spread thinner across the widening distance. The faint glow it returns to us must travel longer, passing through more of the empty dark before reaching our eyes. It is not vanishing, it is simply moving beyond the reach of what our instruments and our senses can hold. There is a quiet melancholy in watching something depart that you have only just begun to know. It reminds you of a comet after its closest pass, trailing away with a tail that grows fainter until it is lost in the starfield. But this is not a regular visitor that will return in decades or centuries. It is leaving for good, carrying its history with it into a part of the galaxy we may never see. Gravity, which once acted like an embrace, now works like an open hand. The sun's influence stretches far, but not infinitely. At the boundary where the solar wind meets the interstellar medium, the balance tips. Beyond that invisible frontier, the sun's presence is little more than another star's distant light. The traveler will cross that line in time, returning to the long, slow drift between suns. You think of what it carries away with it, not samples, not messages in the way we understand them, but the subtle marks of its encounter here. A slight change in speed from passing near Jupiter, a tiny alteration in direction from the pull of Saturn or Neptune, microscopic impacts from dust in our system, perhaps adding a new layer to its surface. It will bear these as part of its ongoing story, even if no one ever reads it. For us, the parting is marked in data. Telescopes record its final positions, refining the last pieces of its orbit. Spectra are gathered while it is still bright enough, each one a small act of holding on. We know these will be the last measurements we take. Once it fades past a certain point, the effort to find it again would take more time than it has left in our sky. There is a deep stillness in this moment, a recognition that nothing more can be done except to watch it go. It is like standing on a shore, watching a ship sail toward the horizon. The ship is no slower than it was before, but your view of it shrinks, and the line where sea meets sky is final. The universe is full of such partings. Stars drift away from one another over millions of years. Galaxies that once brushed past each other move on to separate destinies. Every meeting, every gravitational touch, contains within it the certainty of separation. To witness both is to understand that cosmic time is made of arrivals and departures in equal measure. You remind yourself that this farewell is not a loss, but a continuation. The object was never ours to keep. Its home is the journey, and its path will carry it into regions where other suns rise and set. Perhaps, Far in the future, it will pass through another planetary system, seen again as a faint point of light by eyes we will never know. And there too, it will be greeted, studied, and then let go. In that sense, you are part of a chain. One observer among many, scattered across time and space, each catching a glimpse of a traveler before it moves on. Your part is to record what you can in the short time it is here, to leave a record for those who will never see it themselves, even as it recedes. You can still calculate where it will go. Mathematics traces its path far into the future, showing the arc it will take through the galaxy. But the numbers cannot follow it forever. Beyond a certain distance and time, other gravitational influences, the pull of unseen stars, the drift of interstellar clouds will begin to bend its way. Eventually, its future will dissolve into uncertainty. That uncertainty is not frustrating. It is part of the truth that no path is infinite in clarity. What matters is that for a brief moment, here in the span of human history, we knew it was here. We measured, we wondered, we spoke of it to one another. It became part of our story, even if only for a short chapter. Now, as it moves outward, the sun grows smaller in its sky. The warmth it once felt weakens to nothing. It returns to the cold that shaped it for most of its existence, a temperature so low that even motion slows in the imagination. The light of other stars will take its place, dim points scattered across the black. None dominant, none home. One day, long after it has left our reach, it may pass close to another star. The same gravitational invitation that once bent its path toward us will bend it again toward a new system. Its story will continue there, in another sky, under another set of watching eyes. You find comfort in that thought. This is not an ending, but a handoff, our turn in a relay that spans the galaxy. We have carried its image and its data as far as we can, and now we pass it on to the deep dot soon. It will be beyond even our longest strange instruments. Its name will remain in our catalogues, its orbit frozen in the records of this time. It will join the small, special list of objects we know to be from other stars, each one a reminder that our system is not isolated. And when we look up in the nights ahead, we may think of it still, not because we can see it, but because we know it was here, and that its passing left us a little more aware of the vast, shared ocean of space. Some visitors leave footprints, or shadows, or objects behind. This one leaves only traces in the way light bent, in the way its speed shifted, in the thin signal of its spectrum. There is no fragment to place in a museum, no stone to weigh in the palm. And yet, its gift to us is heavier than anything that could be carried. It leaves us the numbers, lists of positions in the sky, times and dates marked with precision, velocities, measured to the smallest fraction we can detect. It leaves the faint record of how sunlight touched its surface, reddening in some wavelengths, reflecting brighter in others. It leaves the story of its motion, one that can be played forward and backward through equations, showing where it came from and where it is going. But numbers alone are not the true legacy. The real weight is in what the numbers suggest, the slight oddities in its path, the unusual qualities of its shape, the way its brightness rose and fell. Each of these is a seed for thought. From them, scientists will grow models, test theories, and write papers that will outlive the glow of its passing. You realize that this is how science so often works. Not in dramatic revelations, but in the slow accumulation of traces left by things that have already moved on. A fossilized footprint rather than the creature itself. A ripple in a lake when the stone has already sunk, light from a star that has long since burned out. The visitor leaves behind questions that do not have easy answers. Was it shaped by collisions in its home system? Did it carry ices that evaporated differently from those we know? Could its motion hint at forces we did not expect? Each question is a door that opens into another corridor, each corridor lined with more doors. It also leaves behind something less tangible, but no less important, a shift in perspective. You have been reminded that the solar system is not an island closed off from the rest of the galaxy. There are paths through this space that begin far away and will end farther still. We are part of a network of motion that we can barely map, threads of rock and ice and dust weaving between stars. For those who watched it closely, there is a quiet wonder that lingers. To see something from beyond our sun's reach is to touch, however lightly, the broader reality of space. It is a reminder that the familiar planets and moons are only a small fraction of what exists. Beyond them lies an openness too vast for the mind to hold in one image. The data will be archived. It will live in research journals, in observatory records, in the memories of those who tracked it night after night. Decades from now, it will still be cited as an example, a reference point for the next interstellar object we detect. Its name will carry a date, a set of coordinates, a handful of spectral lines, and the echo of the night skies it once crossed. But alongside the formal record, it leaves behind the human stories. The astronomer who first noticed something unusual in the numbers. The students who stayed up late at the telescope, charting its fading light. The people who read about it and, for a moment, lifted their gaze toward a sky they had taken for granted. For them, it was more than a set of measurements. It was proof that the unknown still arrives without warning. In that way, it gives us not just knowledge, but an appetite for more. If such a visitor can arrive without our expecting it, what else might be on the way? Will the next one be brighter, closer, stranger? Will it stay long enough for a spacecraft to reach it, or carry materials that hint at distant chemistry? This appetite fuels preparation. New survey telescopes will be built with wider fields of view, scanning the sky for the faint signs of another traveler. Instruments will be refined to capture more detail from smaller and more distant objects. Plans will be made, spacecraft designs that can be launched on short notice. Missions ready to chase the next visitor into the deep. And here lies one of the most valuable things it leaves us: readiness. Before this, such objects were theoretical, discussed but never directly seen. Now they are real, and the possibility of meeting another is not just imagined, it is expected. When the next arrives, we will not be starting from zero, you think, too, of what it leaves in the realm of imagination. Artists will paint its journey. Writers will tell stories about its origin. Children will hear that once something from another star passed through our skies, and they will grow up knowing that the galaxy is not empty, but in motion. Some of them may become the scientists who meet the next one in the end. The visitor leaves no trail we can follow, but it leaves us looking outward. It turns our attention from the center, from the sun, from Earth toward the edges, toward the spaces where the familiar fades into the unknown. And perhaps that is the most lasting change it could make. Its passing becomes part of the larger rhythm of discovery, like comets in the past that taught us about the outer solar system, like meteorites that revealed the chemistry of other worlds. This object joins the quiet chorus of things that teach us without speaking. It does not need to linger. the lesson remains. And so, in the aftermath of its departure, you find that the sky feels different. Not because the visitor is still there, but because you know that it was. Every empty space between the stars now carries the suggestion of something unseen, something on its way, something that may already be traveling toward us. The corridor of the universe is long, and its doors open in both directions. This time, the door closed behind a departing guest. Next time, it may open to someone arriving. The thought rests quietly. At the edge of your mind, somewhere, something is already moving toward you. It is far beyond the reach of any telescope, far beyond the faintest boundary of our maps, but it is coming all the same. Its path was set long before your species had words for stars, long before your planet had oceans or clouds. Even now, unseen and unnamed, it drifts forward. Between the stars lies not emptiness, but a slow river of travelers. Dust and ice, rock and metal, shards of long-lost worlds and fragments of systems never touched by our sun. Some wander aimlessly, pushed by ancient encounters with planets that long ago turned their faces away. Others follow arcs they cannot change, their futures written in the gravity of a million past moments. This next visitor, whoever or whatever it is, may not resemble the one you have just said goodbye to. Perhaps it will be a dim shard of stone, its surface worn smooth by eons in the cold. Perhaps it will glitter faintly, carrying frozen gases that will bloom into a halo when sunlight warms them. Perhaps it will be large enough to catch the attention of even the casual stargazer, moving against the background like a slow, patient ember. The truth is, you cannot predict it. Even now, your best instruments sweep the sky each night, combing through patterns of light to find the tiniest shift, the faintest speck that wasn't there the night before. For every object you detect, there are countless more that pass unnoticed. And yet, you search not because you expect to find them all, but because you know that discovery is as much about patience as it is about technology. The next unknown visitor may already have been spotted, hidden in old data that no one has looked at closely enough. It may reveal itself tomorrow or years from now. The moment of recognition could come in a burst of excitement or in the quiet realization that something in the sky is moving too fast, too strangely to be one of ours. You know by now that such arrivals are rare, not because space resists them, but because space is vast. The distance between stars is so great that an object can drift for millions of years without ever brushing against a planetary system. When one does arrive, it feels like a coincidence, a chance meeting on a road so wide that no two travelers should ever cross paths. But coincidence in the universe is only a name for the patterns you have not yet learned to see. Perhaps this next visitor will come from a region of the galaxy you have never explored, carrying the chemical fingerprint of a star with a different light, a different heat, a different story. Its surface might hold minerals unknown to Earth, or arrangements of atoms that hint at processes you have never imagined. Or it may be so ordinary that its mystery lies only in its origin, a reminder that even the familiar can have traveled from unimaginably far away when it comes. The solar system will greet it in the same way it greets all things. With gravity, the sun will pull first, turning its straight-line journey into a curve. The planets will reach out next, shifting its path, twisting it into an arc that may carry it close or keep it far away. Every influence will leave its mark, a signature in the mathematics of its motion. You will watch as it approaches, and in the watching, you will begin to wonder, is it alone, Or is it part of a group, with others spread along the same trajectory? Has it passed through other systems before yours, leaving traces in the skies of distant worlds? Is it carrying the dust of other planets, clinging to its surface the way seeds cling to the fur of passing animals? Scientists will prepare, just as they are preparing now. They will have instruments tuned to detect faint changes in brightness, spectrometers ready to read the language of reflected light. They will measure its size, its shape, its spin, its speed. They will compare it to the few interstellar visitors we have known, looking for patterns and differences, building a catalogue of wanderers in the hope that someday the list will be long enough to tell a larger story. That larger story may be one of connection, a quiet network of objects drifting between stars, linking systems the way pollen links flowers, the way rivers link valleys. Or it may be one of isolation, each traveler a solitary fragment, passing through without ever truly touching. You cannot know yet which it will be, but each new arrival is another point on the map, another clue in the puzzle. In the meantime, you wait. Waiting, in science, is not passive. It is the work of building better tools, of improving the ways you watch and measure and record. It is the patient sorting of data, the quiet attention to patterns that others might overlook. It is the willingness to be ready, even if readiness takes years. And when the moment comes, when the next unknown visitor steps into your sky, it will not matter whether you are the one to notice it first. What will matter is that you are here, to see it at all, that you live in a moment when your species can watch the sky closely enough to catch such a fleeting guest, because each one is fleeting. Even before it arrives, its departure is certain. It will pass through, offer its silent presence, and then continue on toward distances you cannot follow. You will have only a short time to learn from it, to let it reshape your understanding, to add its thread to the fabric of your knowledge, and then it will be gone, leaving you once more with that quiet, persistent thought that something else is already on its way. It may be years before you meet it. It may be unlike anything you have seen before, but the river between the stars never stops moving, and the current always carries something toward you. The last visitor showed you how much can be learned from even a brief encounter. The next will teach you something new, not only about itself, but about how to look, how to listen, how to imagine. And in that sense, you were never truly waiting for an object. You were waiting for the next opportunity to ask the universe a question, and to hear whatever answer it chooses to give. The corridors of space are long, and the doors between stars open rarely, but they do open. And when they do, you will be ready to step forward and greet whatever walks through.